James Green, Short Series Shenanigans. So this is going to be episode number 1 of the tailstock repair for the Grizzly lathe, the G0776. So to recap, for those of you that are probably new subscribers to the channel here, and I want to give a huge shout out to a couple of YouTube contributors, Keith Rucker and Keith Fenner. They gave me some shout outs. Kind of recap, I moved this summer, okay, a major undertaking. It was, I don't ever want to move again. If I win the lottery, maybe, and then I'm going to pay someone to do it. The result was, long story short, I had someone move because I had to put everything in storage. I mean everything, all this equipment, for about 2 months until I could move into this house because of just how it was. Anyway, in the process, and I've vented about this on social media, Instagram page, Eagle Dust Off 37. You can see I've posted pictures also on Facebook, social media. The tailstock for this lathe, I removed it and set it aside, and the long story short, one of the movers just threw it. And when I saw it happen, I went livid. Of course, I couldn't see the insides and everything. A couple months went by, got it moved in here, was trying to use the lathe, and something wasn't right. It wasn't locking down. I've already got it set up in the mill. I don't know how many parts this is going to be. What happened was, so 2 things. Number 1, it wasn't that great of a design now that I've looked at it. The through shaft, and I'll briefly describe what's happened. I've already got it fixtured up. There was a lot of setup time and I don't want to take it down. The cam lock, that shaft that goes through there, goes through the front side and only like, it's not even a ½ inch into the other side. It doesn't go all the way through. So when the mover like chucked it, and I watched him chuck it, he like threw it over into a bin of stuff. And I, what the blank are you doing? Well, what? It can't hurt nothing. I'm like, yeah, it, you know, anyway. So when he threw it, it landed on the part that pulls up and clamps, and it fractured all of that in there. So I contacted Grizzly. That part is not like readily available. So this, I got moved in here in October. As soon as I found it, I contacted them. They're like, yeah, we can try to order one from the manufacturer. Should be here before Christmas. I haven't seen it. And so this whole thing, I've looked at a couple ways of where it kind of busted the casting out in a couple of areas. So my fix is to, number 1, the shaft that goes all the way, I'm going to make the shaft go all the way through both sides, because on both sides of that upper casting are good. It was just the areas at the edge that were all broke out. I thought about heating it up and everything, and then you get into, you know, it's warpage, but the main casting, the big outer pieces where this is supported, is perfectly fine. It's not fractured. It was some little areas it's chipped. So we're going to start off first. We're going to make a replacement shaft, which the other one is right here. Okay, so this is where the on the tailstock, where the lever goes, and you can see it only goes through so far, and then where the cam lock is, where the wear pattern, and then you can see the little bitty area right there. That little bitty area is all that was supported, and that actually broke out. So when it landed, it shoved this up and it busted it out of the casting. So I'm going to make a piece that's going to go all the way through. So we got some turning. We're going to use some 1144. That's what we're going to be working on in this video. This and probably the next video will be lathe stuff. Just lots of turning. We're going to get down to the hole we're going to cut through there is 3/4. It's an 18 millimeter. I don't have an 18 mil bit, but we're going to resize everything. So just going through, and because I thought about like TIG welding it up, and then you've got all that paint that's all everything, the Bondo, and then you're going to cause warpage. And I thought, okay, well, the main skirts or walls, if you will, aren't fractured or anything. So we're going to go through with a new piece of material that's going to go all the way through, and not just, yeah, you can tell that's not even a ½ inch through there. I mean, according to the wear pattern. And so we'll get this made, and then we'll go over to the mill. That'll be another video. So let's get started. That's what we're going to be working on. Got some 1144 stress proof, because as with me and other projects, and you guys are probably in the same boat, I need to get my tailstock up and running, because there's some stuff that I need a tailstock for. So with no further ado, I'm going to have you guys down here at the end, and I'll kind of talk you through it. We're going to go ahead and dress up both ends of this while we're at it. First off. And we're going to have lots of turning to do, but first I want to dress the ends up. And this is going to be fun doing this, because I don't have a tailstock to help support this. So this is a challenge. And let's see, I want to use, here we go. Just put a fresh insert in that. Actually, let me rotate this. There we go. All right. Zoom you guys in here a little bit, and you can see the turning action going on. Get you up just a little bit. All right. That just a little bit. There we go. Trying to get my tool centered here. The reason I want to do both of these ends is if I've had a couple of pieces of these stock that I got from someone where they were split through, because this is a drop off of something. Let's go ahead and rotate this around real quick, and we'll dress the other end up. That way I can look through and make sure there's not a split, which I couldn't see it. Let's see. Insert we're using is CNMG 432, and these are actually some Corloy inserts, or Corbeloy inserts, that are have a really good cutting surface, creates a good chip, especially on the stress proof. So now this is where the challenge comes in. So this piece, the overall length is about 7 inches, because I know that I can do that, and that's about 6, so we're about 7 inches. What I am going to do, since I don't have, back you guys out just a little bit here. Since I don't have, well, normally what I'd like to do is come out here, because I'm going to leave this one end down here, the diameter, and we're actually working with, let's see, 1.25 inch material. So, and I'm still getting the feel of where everything kind of how I want it, and in the garage everything's moved around. So what we're going to do, we're going to come out here about halfway, turn it around, end up, and we'll get it down. What we are going to do is go down to 3/4. Okay, is the dimensions we're going to go down to. So we're going to stick out about yay far, and we're just going to start whittling it down. And we're going to check it along the way. So, because we're unsupported out here, we are going to get chatter. And what we'll do is, once we get down close to get rid of the chatter, we'll actually slow the feed rate and we'll slow the RPM down. That's what happens when you don't have anything supported. And it's just, this is a workaround. You're having to use your machine to fix your machine. And so this is where the lathe is having to fix itself, basically. Actually, let's try 460, slow it down. We'll see if we get some chatter. Take a bigger cut, let's see. I mean, it's got some chatter, but we're not concerned about that right now, because once we get down to the size we need to get down to, let's just get an idea so we know how much it was. So 1 inch, 112,000. We got a ways to go still. Yeah, now trying to take a really big cut, you can't do it because it starts to flex, chatter real bad, and without it being unsupported. So I was trying to see if I could take 100 thou. Can't do it because it's going to chatter real bad. So we're going to take about half that, or less than. Whittle at it slow. Normally you want to take a few passes of some deep cuts, but with it being unsupported and having to do this whole thing as a workaround, that noise. And as it gets smaller in diameter, the chatter will only get worse. So you take a lighter cut, it's not as bad. Especially when you start getting smaller diameter. We'll just take light cuts, like 20 or 30 thou passes. That way we don't accidentally mess anything up. So we need to be 750 thou, and we are at 870. So what I do so I don't mess up is I pull out my calculator. This is how I do it so that I don't mess up. Pull out the calculator just because I want to make sure that everyone has their own method to make sure that they're not messing up. So we said we are 874. Actually, minus 750. So 124 thousandths. Let me go grab a mic real quick, because that's just the mic that I want is right behind me. And let's see, is it, or is it in the other? No. Let me go grab it out of my other. Sorry about that. So I'm going to grab my stare at number 216. It's an analog digital. Okay. I'll just take a mic me. So yeah, 871 and 124 thou. Or actually 871 clear 871 minus 750, 121 thou. And you divide that by 2 equals 60 and a half thou. So I'm going to take that in really light cuts because I like sneaking up on it, just because we're kind of hanging out there. So what I'm going to do, so you guys can see what's going on, some DRO action here. And I now got it back a ways. I'm still trying to figure out camera angles in this garage. So let me slide this off so you guys can see the DRO going on. So we're not slinging coolant. So we're going to zero out everything. Alright, what I'm worried about is there, and I'm going to get my mechanical zero as well. Okay, I'm not so much worried about that as I'm worried about dialing in. So, take a spring pass real quick. We'll do that one slow. I'll come back, I'll get a measurement. Now that everything is kind of slowed down, you have your own method of the madness that you like to do. And that's how much tool pressure there was for that last cut. Alright, like I said, everyone has their own method of the madness here. Come back in here and we'll take a measurement. So now that we got our DRO up and everything, we are 864. So let's do the math, just because that's how I keep myself in check. Clear. 864 minus 750 equals 114 divided by 2 equals 57 thou. Alright, so everything's zeroed as far as we're dialing in on the X. And so we said 57 thou. And verbalizing really helps you a lot. I mean, just so you don't mess up. So 57 thou. Let's go ahead and take 10 off. I'm just going to do this in 10 increments. Dial in 10. Actually, let me back up. Get this back down to 0. All right. All right, so we're going to dial in . All right, let's try that. Now, whenever we go, because I don't want this to be, you know, like an air bearing fit or whatever, because I want to allow for junk or whatever, and then when we go to drill that hole, I'm going to leave this a little big, because when I go to drill that over there in that casting, and I'll take you guys and walk over there before the video ends on this segment, is I will show you because you know when you drill, and I don't have, well, I'm going to have to look. I may try to ream it so I get everything straight. So I'm going to purposely leave this big because I know when you go to drill through both pieces, I want to allow for, if that's big, I don't want it real sloppy and I don't want it super tight, but we want to get it close. So now we are at 849. Okay. All right. Really good with these inserts. Nice small chips, not stringy. Alright. Come in here. This is just something that I like to do. 819. We just keep sneaking up on it slowly. Like 760, just because in case when we drill, if it ends up big, I can always come back and turn this down to get it to fit where I want. Just because I know, because I've already set everything up and kind of started drilling, that's a hardened piece over there already, so the bit that I have, it's going to be interesting. So I'm purposely going to leave this a little bit bigger. And so we're 783. Let's take off another 10. The last cut here and come back and size it down just in case that thing gets really big on me. I don't want to have to make this shaft again. Matter of fact, I'm going to stop right there before I come back and take a measurement. Let's see where we're at. So yeah, we're 750, 54 right there. I'm gonna leave it a little big, 754 thou. We'll call that 2 size as far as that goes. All right. Chips get caught down there. All right, I'm gonna come over here. I'm gonna break this edge to get rid of that sharp part. Yeah. All these little workarounds here. All these little workarounds here that you have to do because you don't have your tailstock. It makes you think about things, you know. So now what we're going to do is we're just going to flip this around. Now, because this side is going to be the side that's going to be large, you know, I'm not going to waste the rest of the time showing you the rest of the turning of what I'm going to be doing. But we're essentially going to make, like I said, this, obviously it's going to be bigger and it's going to go all the way through. And so we're even considerably bigger than, you know, what that is. So I don't want to leave that there. What I'm going to do is set that there. Actually, I'll set it right over here. I'm going to walk you guys over here real quick and show you the setup I have, and that's where I'll bring you in on the next video here. Get over here. Yeah, it took me a little bit to kind of figure out how I wanted to do the setup on this. So let me move this stuff out of the way here. All right, so here we go. We had to put our angle block in here. Had to use a real large because I bolted down, supported here with a jack. I got some spacing up under here so I could actually use my leveling jack. Now we're clamped here. We're not crushing, so I'm not worried about disturbing the bore here for the tailstock. Okay, that still moves freely. But we got it clamped in place because we're going to come in here with this bit, this 3/4. I don't know how well it's going to do. I've already done just a little bit of a kind of a plunge cut to see if we're centered, and we're centered. And that's where we'll come in on the next video. I'll show you guys here this. You know, and the reason I chose this, it's long enough, and plus it's actually, you know, I don't know what if you call it, it's a 4-fluted, you know, reamer, drill bit, mill, whatever. It had an MT3 taper on it, or actually had an MT2, had a Morse taper 2 on it, and I turned it down to a 9/16 shaft because I didn't want to go through the hassle of putting in a Morse taper adapter and switching out. And there's not a lot of Morse taper stuff that I use, and I've got like 5 of these bits, so I turned one down with a round shaft on the end. But so yeah, here's the other eccentric pieces that fit on that shaft. Now I'm going to have to make sure that I fit that eccentric to that shaft and all that good stuff. But there we go. But yeah, it had landed on this with this whole piece, that plate that pulls up, and it broke the casting out of the bottom. And I'll show you once we get through drilling the bottom of this thing out. But there you go. Part 1 of the Grizzly G0776 tailstock repair. So follow along. Thanks again. My public email address, if you guys have any questions, eagledustoff37@gmail.com. Glad to be in the shop. I'm going to be getting stuff set up to where I can do YouTube live videos. That's the game plan. That's the goal. So there you go. The lighting is helping with these LED lights. These are awesome. Everything in here is LED, and I love it. So thanks again. Appreciate it, you guys and gals. Again, huge shout out to all my fellow YouTube contributors out there. Again, you guys are awesome. Again, big thanks to Keith Finner there on his porthole video. That's pretty interesting. There's always a way to fix something, just like him with the portal. I'm having to, you know, fix something that someone broke for me, along with a few other things. So there you go. Like I always say, and I mean it at the end of every video, take care of yourself and take care of your family, because remember, at the end of the day, you and your family is all you got. Till next time, get out in the garage, and if you have to fix a tailstop, hopefully this video will help you out. Talk to you later. Bye.